Aloha, and thank you for watching. I'm Representative George Fontaine, and you're watching The Fontaine Factor. Tonight we have a very special show concerning Hawaii's reefs, their health, and in some cases perhaps their demise, and what the overall health of the reefs are not only around Maui, but also the entire state of the Hawaii and the northwestern Hawaiian Islands as well. So we have some very notable guests here this evening to talk to us about this subject matter. I'd like to introduce Mr. Russell Sparks. Mr. Sparks is with the Aquatic Resources Division of Department of Land and Natural Resources. Is that correct?
That's correct. Yeah.
And also joining us this evening is Dr. Cynthia Hunter, who's an Associate Professor of Marine Biology at UH Manoa.
Right.
That's correct. Thank you for coming. And also with us this evening, we have Mr. Jeff Kuwabara, who is also with UH Manoa and is the Marine Option Program Coordinator. Wow, that's a mouthful.
Yes,
I guess we'll find out
is.
exactly what that's all about later on. All right. Well, as you heard me talk about the opening, there's obviously a lot of concern about what's going on with our reef system. And for those of you in the audience who are not scuba divers or go out regularly and snorkel, over the years we've seen a degradation of our reef system, and particularly in South Maui, in the South Maui Bay area, the Malaya Bay area, there's been a lot of degradation of the reef. In fact, I think it's pretty much almost dead. Mm-hmm. So, Russell, what do you do with aquatic resources, and how are you involved in this this preservation or restoration, perhaps, and maybe in some cases?
Yeah, well, our division is responsible for managing living resources in the water. So one of my positions is an education outreach specialist. And one of the things that I've been involved with for the last 13 years or so is kind of working on the marine monitoring program. And monitoring is to get out there and to actually measure change on the reef over time. And so we set up a bunch of sites, and we go back year after year and we monitor what's happening. And in a very simple sense, we look at the percent of the bottom covered by coral and how that changes over time. If there's less coral year after year, that's not a good sign. If there's more coral, then that tends to be a good sign. And we look at that change over time and trying to figure out what's driving it. You know, what kind of things are happening that are stressing out the environment, that are causing that. That's important for us to get out to the public so that they understand how their actions affect the reefs, but also to use that to drive management decisions. We're going to set up areas protected from fishing, or maybe put pressure on landowners to change land practices, or maybe other types of things that might affect development and so forth. We want to have real data so we can show what you do on land, how that affects what happens in the ocean, things of that sort.
Okay, now you've brought some slides today to kind of give us an overview of what's happening, at least with Maui. Would you like to we'll put those slides up and we can have you maybe kind of narrate through what we're looking at?
Sure. We'll go through it really quickly, but yeah, if we see what's up there. Okay, so this slide is basically showing all of our monitoring of coral reef in terms of percent coral cover. So very simply, you look at the reef in a two-dimensional frame and you see how much of the bottom is covered with living coral versus other things. And you look at that change over time. The red sites are all significantly declining in coral cover, so that's not generally a good sign. The black sites are staying more or less unchanged, and if there's a lot of coral, like at Oluwalu in the middle or down near the bottom at Molokini, that's good, actually. That's what you want. There's a lot of coral, and it's basically staying that way from year to year. And then the one green site we had was increasing. So back to that slide, I mean, you can see that a lot of the sites that we're doing monitoring on have significantly declined, and some of them quite substantially. You talked about Malaya Bay. There's also Honolua way up on the north on the point there. Kahekili, which is one we'll talk about at the end of this presentation. But I just want to point out that a lot of this degradation is occurring quite quickly. We can move on, and I'll show you just some examples of what that looks like. Molokini is a marine life conservation district, but it's also out in the middle of a channel, so it tends to be buffered from a lot of those land-based influences, sediments and nutrients and so forth. And here the reef's about 75–80% coral cover and hasn't changed over time. But yet you can see from looking at the progressive series of the same section of reef that it did change. You know, different corals are growing more, it's growing up. it's always increasing in complexity. You know, it's staying ahead of erosion. So that's actually what we want to see in a healthy reef. The next one, this is Honolua Bay. And in Honolua Bay, we have these big pulses of sediment that come in from time to time. In 2000, you can see, you know, there wasn't much change at all. There's this purple rice coral in the lower quadrant of the photo. Mm-hmm. And then in 2005, all of that disappeared. And that coincided with a big sediment event. There was some construction in Kapalua, heavy rain during the winter, January, and that flushed into the bay at a time when there was very little wave energy. And that dirt settled out. Purple rice coral is not necessarily well adapted to sediments. It's more of a high wave energy coral. And it just completely disappeared from the reef in 1 year. So that's a dramatic example of what happens from these kind of sediment events, or what can happen. The next one is Kahekili, which is North Kaanapali Beach, or Old Airport Beach for people who are familiar with different names. At this site, it's kind of a stressed reef. We've lost about 50% of the coral cover. There's periods of time when there's a lot of seaweed smothering portions of the reef and filling all the gaps. But over time, the main thing you can see is the coral's still there, a lot of the structure's still there, but it's a lot less and it's more patchy. So this is one where we're actually taking some fairly intensive management action to try and turn that around.
Well, in actuality, you know, I've dove there since back till 1974 in that general area, and I myself have seen the degradation to be even worse, because I remember it when I was a teenager, diving off of that reef, and there used to be beautiful, colorful coral practically right up to the shoreline. And then as development came in and they put in the concrete embankment into the Honokauai stream, where before it had mangroves and other kinds of vegetation which helped prevent a lot of that silt from going out to the reef. And then once that was done, once they put in that concrete embankment into that stream, everything from there all the way down to this, where this park area is, began to change. And it became almost yearly that I had to swim out farther and farther to get out to the reef to actually be able to see life. And I haven't dove in there in many years. I'm looking at that photograph right now that you had up, and I mean, this is drastically different from what it was in the 70s. So, you know, it's pretty frightening.
Right. Yeah. And you know, basically, from where that drainage ditch Honokauai is north, you have very little reefs, period, anymore. But south of that, at this old airport beach area, North Kaanapali, there's actually still some fairly nice reef structure there. And one of the main threats now that we're seeing is that's where the wastewater treatment plant is. The wastewater is treated and injected into injection wells. That then percolates up right into that area, you know, in knee-deep water, right outside of those major resorts, the Kaanapali Ocean Resort and the Kahekili Beach Park. Wow. That's fueling a lot of the algae growth. It's also stressing the corals. They did not evolve with all that water and all the nutrients in the area.
The nitrates and all the rest of it.
Yeah.
Okay, so let's look at the rest of your slides. I'm sorry to interrupt you.
No. I'm going to back up one. Okay, yeah. All right, that's where we were. Okay, move forward. That just kind of shifting gears. I mean, there's two, if thinking very simplistically, there's two major things that are driving a lot of this degradation. One being we've altered substantially the fish populations, and most of them, herbivore fish, feed on algae and keep things kind of in check on the reef. The other being what we just talked about, we tend to put more nutrients into the system, and that's fueling the growth of seaweed. So we're fueling faster seaweed growth, we're reducing the animals that eat it. And as a result, we tend to see these problems on the reef. So what we're doing at Kahekili is we're actually addressing two parts, but immediately we're addressing the herbivores, the fish on the reef. We're trying to bring that up by protecting them. So moving on to the next slide real quickly. I just want to point out, I didn't want to get into all the different graphs that we have, but this is just a comparison of fish stocks throughout the state in relation to population. So if you start all the way on the right side, on the island of Oahu, we just categorize Oahu all on itself as being fairly populated. You can see the fish population is fairly low in terms of biomass. As it moves back, populated areas of the state would be Kihei, Lahaina, areas like that. It's a little higher. Then you have more sparsely populated, and then last kind of remote or isolated areas. You can see that the fish biomass increases accordingly. For comparison, on the far left, we have the northwestern Hawaiian Islands, which is, pristine, more or less unaffected by human fishing and other things. And so that just kind of was a way for us to benchmark what's happening. The key there is even with all of those fish in the northwestern Hawaiian Islands, 50% of them being predators, there's still much more primary producers or herbivores, grazing fish, there than there is even in the remote, isolated, way out of the way off of the cliffs in Hana or something areas. So it just kind of showed that that herbivores, what we've done from fishing has drastically reduced our numbers to the point where we're setting things up to be out of balance. If we move on to the next slide, I just wanted to talk briefly about this North Kaanapali area where, because of the data, the reef data we showed you earlier, we actually implemented a management plan where we're protecting key herbivore fish. So 3 families: the parrotfish or the uhus, the nenui or the chubs, and the surgeonfish. Everything from manini all the way to the kala, things of that sort. And sea urchins. Sea urchins are very important grazers as well. And also, one more thing, we make it illegal to feed fish. And it's important because this is a resort area, and tourists come and they want to see all the fish, and they think they're doing them a favor by feeding them, and they're coming into the area. But if they're doing that, they're no longer feeding on what they should be feeding on, which is the algae on the reef. Mm-hmm. So it's a very simple rule. It's nothing very complex about it at all. But along with this, we're still encouraging quite substantially fishing. We want fishermen to be there to, enjoy the resources, as long as they're not catching the fish that we are protecting. So if the reef improves, we want them to experience that as well.
Great. Folks, if you're just joining us on our show, you're watching the Fontaine Factor, and tonight we're talking about the reefs around the county of Maui, but also statewide and the northwestern Hawaiian Islands. And my guests this evening are Russell Sparks of the Division of Aquatic Resources, Dr. Cynthia Hunter, the Associate Professor of Marine Biology, and Jeff Kuwabara, who is part of the UH Manoa program on the Marine Option Program. Sometimes our viewers come in halfway through the show and they go, what the heck are they talking about? So,
right.
Dr. Hunter, so with UH Manoa, maybe you could get into more of the causal effects and some of those things, what we can do as a community, areas where people can get involved. I mean, obviously this is a very important thing, and I want to stress to our viewers that the coral reefs, and I'm sure you folks will back me up on this, is just not affecting the tourists that come here. This actually is a quality of life issue for everyone, even though we may not particularly see it every day in the water. So
that's right. Well, the university, of course, is in the business of doing research and education. For the last 10 years, we've been working with the state and the feds and local community groups to work on ways to actually control one of the biggest threats to Hawaii's reefs right now, and that's alien algae. They are taking over large amounts of reef areas. It's a big problem. And so working together, which has been really neat, in a group called HIMAG, the Hawaii Island Marine Algae Group, we developed ways to actually remove these alien algae from the reefs. And now, also working with the state, we are looking at enhancing herbivores in the form of sea urchins, growing sea urchins at a Sand Island site. This is a state facility. And we'll be working with the state this summer to help put the urchins back on the reef and monitor whether or not they're going to help us in chewing up the alien algae that are overgrowing our coral.
Okay, so in terms of algae that's also fueled by the injection wells, and I'm not familiar with the injection wells as whether this is just a Maui problem or whether or not it's a problem throughout the state. Do all of the sewage plants basically do this practice?
I believe Maui's the only one with injection wells in the state.
It's not 100% true. I mean, it varies from place to place. Maui, the county sewage treatment facilities all use injection wells as their primary disposal means. They also do a fair amount, especially in your district, they do a fair amount of reuse. But the infrastructure to redistribute that water is not adequate to use all the water in that respect. I think on Oahu they have some reuse, but the primary way in most places is open water outflow. And then on the Big Island, I think there's some injection wells as well.
Now, does the University of Hawaii do any type of outreach programs in terms of the community and going out and doing education in the community? Or do you folks get involved in that at all, or work with other groups that do? Or?
Tons. A big element of this HIMAG group was developing public support by educating people about the problem. And then once the community knew, that developed the political will to provide funding for the state agencies to address the problem. So that's where it all starts. But education is the bottom line.
Sure. We're also involved in an effort to help educate volunteers around the state. So I believe it started on Maui, ocean awareness training, in conjunction with the Whale Sanctuary and Sea Grant and some other entities. And they run a series of training lectures, and it's open to people who are interested in getting involved in volunteer efforts with the ocean. And they ask a number of educators and experts in the field to then, help train these people up on coral reef biology and ecology, cultural things as well, and just give these volunteers, these willing participants, a little bit more ammo to go out and do a good job and do their part.
This past summer I had an opportunity to go out and visit the bay. What is the name of the bay?
Kaneohe?
No, not Kaneohe. The one that's on the south end.
Hanauma.
Okay. And that program over there, I didn't realize how extensive it was, but they actually go through and do an educational component before they'll even let you step foot on the beach.
Mm-hmm.
Mm-hmm.
And they've actually reduced the number of visitors. I think at one point in time they had up to 2 million visitors a year that actually came through that.
And more than that. Yeah.
And then they dropped it down, and limiting the access, which just really actually helped preserve it. But I'm wondering, in terms of a state initiative and really as policymakers, how we can help do that educational process, I think, with visitors that come here. We do a lot of posting of signs, don't bother the honu and don't feed the fish and all that. How many people who are visitors actually read that? So how do you, is this something we work with the dive industry in terms of providing information, or do we work with the hotels?
I think you have to hit them on all fronts.
That's the answer. Every one of those is a great opportunity to reach a different group of people.
Okay. So aside from the algae, how much of the impact do you see coming from just the presence of human beings in the water?
It's hard to quantify what degree is affecting what. I mean, certainly if there's a lot of people and they're inexperienced and unaware of the impact they're having, kicking the coral, stepping on it, grabbing it, it's going to have an effect. If you have a huge rain event and you've altered the land so you no longer have a wetland to absorb that, and it all pours into the ocean like it does in your district in Kihei, that's having a huge effect on a much broader scale as well. So it all kind of adds up, right? And then the nutrients fueling algae are affecting it. So everybody likes to point at one thing or another, and really all of these things are important, and we need to start to affect and change whatever we can.
Sure, you
if
look
we're
at
going to turn the tides and
the old practices. You look at even Hanauma Bay. They dynamited a section of that reef in the 50s to lay down some cable, and the result was that reefs normally protect the shoreline from erosion. Without the reef, they experienced quite a bit of erosion, so they rebuilt that reef, and so you go there and you see the boulders out there.
Wow.
Well, coral reefs impact all of us, maybe in ways that we don't even recognize sometimes. There was a report to the federal government just last October estimating that the annual value of coral reefs in Hawaii was about $379 million. So that's in the collective value. So not just 7 million tourists every year, but also coastal protection, fisheries, and even pharmaceuticals. So reefs are important to us all, and we just need to let people know that.
Well, they're obviously very important in terms of preserving coastlines. You know,
And surf breaks.
and surf breaks and all of those things. And but I get the sense a lot of people they don't really understand that importance so much. You know, that they're just something that, you know, well, that's, you know, the fishermen go out and, you know, they're the primary users of the reef, but really it's a whole food cycle as well too, right? I mean, we're talking about reefs affecting, you know, predators that are deep water predators because they feed off of the larvae and everything else from these fish that are out there in the deep water. And we've seen, you know, drastic reductions also from overfishing, I'm certain, but, you know, I can remember when we had aku runs, you know, between Kahekili and Molokini, and we used to have aku boats that used to come out, but and the water would boil with fish. But now that's no more. I mean, it's very rare unless, you know, a warm current comes down or comes up rather, and takes schools of fish back up towards the Hawaiian Islands that we see these large schools of ahi or aku tuna coming in and feeding. So what's that relationship like, you know?
Well, when you see that kind of change in that short a period of time, you recognize that we have to pay attention. And we hear our colleagues at DAR say all the time, we don't manage the resource, we manage the people, right?
Right.
There are too many of us.
Right.
Well, I mean, people aren't going to go away.
No, they're
so
not.
So we have to come up with innovative strategies, correct, in order to ways that we can address that. You know, and it's always tempting to want to fool with Mother Nature in some respects. I mean, you were talking earlier about, you know, putting sea urchins out.
Right.
You know, and I think about all the horror stories we've had in the past where we brought ta'api in.
Right.
Remember that, those days? And it was going to be like this food source, right? It was going to be this great thing, and we were going to have all these ta'api. Well, it turned out nobody wanted to eat the ta'api because they didn't taste good. So nobody fished them, and then all of a sudden, boom, the reefs were taken over by ta'api.
All the way up the chain.
And I believe they actually had a program one time where they were giving a reward for people who would actually catch them. Is that true? Or?
No, they had a program Sea Grant sponsored many years ago where they were trying to promote people to feed on ta'api. So they developed recipes and they had cards and they were trying to push that. Actually, interestingly, you know, it's kind of caught on. At least on Maui, people are actually targeting ta'api and enjoying, you know,
you see them at the grocery store.
And they're eating them and they're frying them up and they're like, hey, you know, this is just as good as kole or a kuli or something, and you know, we're doing the reefs a favor by removing them. And I've had fishermen complain to me that there's not as much ta'api. They're having a hard time catching them.
Oh, dear.
So,
interesting. That's really a big shift.
Yeah. Plus, you know, any kind of invasion of a different species, you have a boom where there's a lot of them for a while. Then they start to kind of reach an equilibrium, right? And that's what I think we saw with ta'api. There was a lot. You saw them all the time on the shallow reefs. Now there's not as many.
Well, I want to get back to your question about the urchins, and it's important to remember that we brought in these invasive alien algae for the most part, intentional introductions. These urchins are native species. These are Hawaii, and they're also very herdable. We feel that if they started to multiply and become very numerous, we could encourage fishermen to go collect them because they can be harvested for their gonads for sushi in Japan.
Right.
And in the meantime, as they're growing up to that size, hopefully they'll do that ecological service for us on the reefs and eat the algae on the way.
Okay. And it's important to note that they're very effective at removing algae.
Oh, I've seen them, and of course when one gets broken, you know, of course they provide us food source as well too, because the wrasses all come in and they like to eat those things as well. I mean, I see them
on Maui recently at Malaya Bay, where we were starting to think, hey, these guys are raising urchins now. Maybe we can outplant urchins. I went out there last year and looked, and there was a natural recruitment of adults coming up from the deep, and it was like a front line of an whole, you know, army battle or something. Where there's all this algae here, and there's all these urchins here, and behind them there's just bare rock.
I hope you took lots of pictures.
We did, and they just came right on through. And several months later when we did our surveys, it was totally different. You saw crustals, coral, and algae where you never saw it. You saw coral recruits.
Right.
So whether or not they stick around
Right.
and continue that, or whether it's just some kind of natural pulse for whatever reason,
Right.
I don't know. But they're there in the nature, and they do this naturally. So it's not out of the ordinary to expect that to be part of our plans for the future.
Well,
to maintain these reefs.
Hopefully, now the Rory was introduced as well too, I believe, and
Yeah.
you know,
Same
then
time.
it's been a big problem because in fact I knew a friend of mine who actually got Ciguatera from eating one of those, and you know, so that's a big issue with the Ciguatera, which they say comes from starts at I guess the microbe level and works its way up into the food chain through the reef fish and then onward up into the like the Alua and everybody else that eats. So as it goes up the food chain,
Sure.
the Ciguatera still remains. So I guess that's another issue, and maybe that's even another show we can talk about diseases of the waters in Hawaii in terms of things that have occurred with, I guess, meddling or whatever happened in terms of how things evolved in terms of the various diseases and those kinds of things. Just quickly, I have just about a minute left. Do you want to mention anything about your marine option program?
It's an undergraduate certificate program that is really designed for people of all majors. So it's a way for everybody to add an ocean flavor to their degree. So you can be a business major and do a business plan on an ocean-going business of some sort, maybe renting surfboards, or you can be an art major or a marine biology major. But the idea is to get hands-on experience and test out the professional waters, if you will, to see if you're a good match for it or it's a good match for you.
Excellent. So it gives some people some extra tools depending upon whatever they do in life to have that extra knowledge or resource or toolbox to make,
Sure.
you know,
and we've trained
decisions.
a lot of marine scientists. We have a field school where we do coral reef studies and every summer, and the people that have gone through that end up working in
Great.
places like DAR.
Well, folks, we've run out of time. I want to thank you for
Sure.
coming in. Folks, if you have any comments or concerns about today's show, please write me, repfontaine@capital.hawaii.gov, repfontaine@capital.hawaii.gov, and thank you for joining us. Aloha.